Now, let me consider the case where I have parallel paths in the process rather than alternative paths. I can wonder then, what is the cycle time of a process where I have first A and then I have B and C in parallel? Now, the first thing is to determine what is the cycle time of this region here where we have B and C. Because B takes longer, even if C completes, it doesn't matter, that block keeps going. The AND join will not fire until we have completed both tasks. Therefore, the amount of time this block takes is 20, the maximum of the two tasks. And the cycle time of the process is then 10 for A plus 20 for the parallel block. Let's consider now another case where I have what I call a rework loop. A rework loop means that an activity may be repeated, meaning performed multiple times, and that could be multiple activities, not just one, but there is a block that is repeated multiple times. Like, for example, here I have an activity A, 10 minutes, followed by a rework loop where I perform B at least once, that's 20 minutes, and then I might repeat it. What is the average cycle time of this process? Well, again, as in the alternative path scenario, it depends on how often I take the branch of the decision gateway that goes out of the loop and the one that stays in the loop. Let me assume that the branch that goes out of the loop is performed 100% of the time. This means always when I get to the decision gateway, I immediately after go to the end event. This process is then equivalent to performing A followed by B once, and then I exit the loop, and then I finish the process. And that will be 10 plus 20 for B, and that's 30. Let me assume that the branch that goes out of the loop is performed, let's say not 100% of the times, but 1% of the times. Very, very infrequently. Most of the time I stay inside the loop. What happens then is that the cycle time of the rework loop explodes. And if we think a little bit more about it carefully, what happens is that the cycle time of a rework loop is equal to the cycle time of the body of the loop, which in this case is 20, that's activity B, divided by the probability of the exit branch, in this case 0.01. And 20 divided by 0.01 gives you 2000, and the cycle time of this process is 2010, enormous. Now let's take the case where this is a more sensible case where I take 80% of the time the branch of the XOR split that goes out of the loop, and 20% of the time I stay inside the loop. In this case, the cycle time of the process is 10 for activity A plus 20 for activity B divided by the probability of the branch that goes out of the loop, which in this case is 0.8. 20 divided by 0.8 gives me 25 plus 10 for A, that gives me 35.